Let's over chapter 4.4, heat and thermodynamics. So we're going to start by talking about how heat can be transferred. There's three different ways that we're going to focus on that heat can be transferred. So the first is conduction. So this is the transfer of thermal energy between touching materials or within a material where the particles within the object are touching. Okay, so it's going to happen slower in gases, and this is just because particles are going to collide less often. So in gases, we see that the kinetic energy is very, very high, but they also space themselves out. So like the particles that make up a gas, like the atoms or the molecules, they're going to be bouncing around very rapidly, and they're going to fill the space that they have available to them. Okay, so they're less likely to bounce into each other. Okay, and remember, for conduction, you have to be touching. Okay, so more often, conduction is going to be better suited for solid objects. Okay, because solid objects, all of the particles are touching together. They're still moving, but they're just vibrating back and forth. They're not bouncing around sporadically like they are in gases. So metals are actually really good at conduction. Okay, so these particles are vibrating back and forth, but also what makes metals so good at conduction is that they actually have these free electrons that can move about the substance that allows the thermal energy to transfer very easily. Okay, so we have things called thermal conductors and thermal insulators. So things that are thermal conductors are going to be very good at transferring thermal energy. So these would be things like our metals, like metal pans. Glass can be a pretty good thermal conductor. It just depends. And then thermal insulators. These are going to be things that don't transfer energy very well. Okay, so things like plastic. Air is actually a pretty bad thermal insulator because it is made up of air particles it is a gas that's bouncing around sporadically. Okay, so whenever we talk about conductors and insulators, a lot of the times it has to do with wanting to achieve a certain goal. Okay, so if we are wanting a conductor, it might be that we want a thermal conductor. It might be that we want to cook a piece of meat, or we want to transfer heat to an object, whatever it might be. Okay, so we would be thinking about substances that allow for that, like metals. Whereas a thermal insulator, maybe our goal is to prevent heat transfer. So if like we're trying to keep food warm while transporting it, or if we want to keep like heat out of our house whenever we're cooling it off with air conditioner, okay, that we would be thinking about thermal insulators for that. The next type of transfer of thermal energy is convection. So this is the transfer of thermal energy when a fluid moves from one place to another. Okay, and remember in physics, the term fluid is the term for gases and liquids. Okay, so a lot of the times we could see convection in both things, a liquid or a gas. So some examples of convection are like ovens. And so with convection, what we see is that hot air rises, or hot particles rise, and then the cooler ones drop. So hot air rises, and then the cool air drops. So in ovens, they use this convection current to allow the heat to circle around. So there might be like an element at the bottom of the oven that pushes out heat. That heat is going to rise up to the top, and as it cools, it's going to drop back down, but then get heated back up again by the element at the bottom. Okay, we also see this in our oceans that causes currents. In weather, that's the movement of a gas. The air is going to move from high to low areas. Okay, so high would be your high temperatures, and then low pressure. A lot of times it's with pressure with weather. And then also in Earth's core. Okay, so the molten lava acts in this convection path as well. Okay, the last one we're going to talk about is radiation. So this is the transfer of thermal energy by waves. Okay, so if we think about the sun, okay, we are separated by the sun from space. Okay, so in space, there's no air particles, there's no matter or anything to transfer that energy through, like we see with conduction and convection. So both of these rely on atoms to transfer the energy. Okay, radiation, there is no atoms, or there might not be any atoms in the case of the sun. Okay, so we're still able to feel the sun's energy because it gives off radiation. Okay, so all objects radiate energy, and so as temperatures increase, they're going to radiate more energy. Okay, so if we look at this, a cooking pan shows all three types of the energy transfer. Okay, so the element on your stove is radiating heat, so it's pushing out these waves. So even when you're not touching the stovetop, you can still feel the radiation, the waves coming off of it. Okay, within, if we had like water, we're trying to boil the water, within the water we have convection happening. So the hotter particles down at the bottom are going to come up to the top, and once they cool, they're going to drop back down to heat back up again. It creates this like vortex or circle path within the water. Okay, and then we can feel conduction by touching the metal handle. So even though the metal handle is not directly touching the element, the heated element, it does transfer heat because of conduction. So the heat is being transferred through the metal particles down the handle.